Now let's calculate feeder number 3. Now notice feeder number 3 from our figure 3-1 in the workbook, and we're now working on page 3-10 of the workbook. And then notice our feeder number 3 at the very top left-hand side of page 310. We pick up the loads. And notice we have fluorescent lighting loads. We have recessed luminaire loads, receptacle loads, isolation receptacles, regular receptacle loads. And then notice now in the item number 1, we perform the calculations based upon continuous and non-continuous loads, and also apply demand factors to the receptacles, the general purpose type receptacles. If we go to Article 100 and define the general purpose receptacles, that are basically says 2 or more outlets on a circuit is considered general purpose. And notice after we do the calculations in item number 1, we come up with a total load of 387.005 amps. Now in item number 2, we are sizing basically the Kva rating. And after we do the math in this item number 1, along with step 1, we come up, after the math is performed there, as you see in the illustration, we come up with 139.322 Kva rating. Step 2 on the right-hand side of page 310 at the very top, we select the transformer using the Acme chart in the back of the workbook, and basically it's 225 amp. Now we just used that particular transformer. You could use any size transformer to meet your need. And notice we come up with a 225 kVA transformer. Now after the solution, we apply step 3, and we do the calculations there, and based upon 13,800 volts times the square root of 3, 1.732, and we do our math as shown in that step 3, we come up with 9.4 amp. Now notice we would go to our table 450.3a, and we would pick up, in this case, 600% to size the overcurrent device. So 600% of 9.4, you could use up to, say, 56.4 amp. And you could round that down to a 50 amp protective device is required, I think, in that table 450.3a. Now we select the overcurrent device from table 240.6a for this high voltage, so it's simple. And that's usually all the testing agency do that for simplicity's sake. They let you do that. We know that we would actually go to a standard to pick up the size overcurrent devices for high voltage. Now, then the solution and would list that 50 amp. Now moving into item number 3. We're wanting to calculate the copper conductors based upon the 90° C terminations as outlined in 110.40 in the NEC. And notice in the step 1, table 311.60C 77, as well as 110.40, we would select number 6 conductors with this overcurrent device of 50 amps. And notice there would be 3, L1 and L2, that we would select there. And then I would suggest you review the notes 1 through 4 below for some additional information that would be helpful to you. Now notice we size the transformer off of the 125% continuous load calculation. Some engineers will size the transformer over 100%, or some cases maybe with some demand applied to it. Just check with your monitor of the tester taking committee and see if you used 100% or just 125% of the load. Many of the test taking giving type agencies, they use the 125% rule. So just check that out and be sure you're on safe ground. And I think this would give you the procedure for calculating feeder number 3.